So, how are you people? How you all are doing today? All fine? So, on the last class, in the last class, we did, uh, I think so, algorithmic analysis, part one, right? You know, okay, Vishal, that's great. You did that, and yeah, I have one more way. I have one more way. Like you remember in the doubt class, we discussed about the two loops way, if you remember. Those first approach were taking two loops, you know. So we'll also do by that thing. Okay, we'll also do that particular thing by two loops also. Okay, so that we'll practice that also. Fine. Okay, I don't know when, but most probably in this week in the doubt class or in some revision class. Okay, we'll do that for sure. Algorithmic analysis part 2. Okay, okay, so I hope yesterday's session were helpful to you. Okay, try to use. Okay. Okay, Nishant. Algorithmic classes are very interesting, na? ठीक है, चलो. That's great that you are enjoying the classes. Perfect. That's what is expected as of now. है ना? So I hope everyone has joined till now. You know, please try to join people on time because I was waiting for you all to start the class because I see that in the starting minutes of in starting few minutes attendance are very less, so I cannot start. है ना? So, yes. So, yeah, in the previous classes, what we have discussed, first of all, we discussed about the algorithmic analysis, right? Second thing we discussed about the goal of the algorithm analysis. Yes or no? What is the goal of algorithmic analysis? Then, after quickly, we started with the types of analysis. If you remember, okay, in this particular types of analysis we had two types. The first one were very basic. It was like foolish way to do that. It's like experimental analysis. And the second way, which was that people remember, everyone, which was the second type of analysis? Asymptotic analysis. Perfect. Fine, we saw many examples with this particular asymptotic analysis. The fourth thing that we had discussed is like the types of measurements. Types of measurements. In that particular thing, we did the best case, we saw the average case, and we saw extensively the worst case. Today also we'll see this everything in detail. Okay, I'll touch this everything in detail. And the fifth thing that we did was the big O notation. Yes or no? Any doubt in this particular thing? Because today we'll start the no. We do something like we do some basic thing on this, whatever we have learned, and then quickly we move further with the advanced part of it. Okay, so this is what we have covered in the last session. Mostly nobody will ask about the best case and average case because everybody will concerned about the worst case scenario. Like if you see in the interview also, and if you see in the examination also, or if you see in any corporate sector like data analysis also, they will not ask about the best case and average case because everybody will be concerned about the worst case scenario. And nobody will ask that if this is your product, then how less I can sell. Everyone will say that how maximum I can sell so that I'll generate more profit. Yes or no? You know? Yes, Nilanjan, today also we'll do that. Fine. Okay, don't worry. Nishant, have you attended the yesterday's class of doubt session? that will be the best case. No. So that is why I recommend that if you have any sorts of doubt, then please attend the doubt session, because yesterday, if you see now, Nishant, we discussed everything in detail. If you ask anybody, like I think Nilanjan was there, right? Nilanjan was there, Hariharan was there, and many other guys were also there. Like Aradhya was also there. So we discussed everything in detail. So I'll highly recommend, please watch that up. And also, if you ask about today's session, today also I'll touch some of the basic concepts. So if you haven't understood anything, please ask me. Okay. But I recommend that first of all you see that particular thing, then only this will be the making sense. This class will make sense. Fine. Okay. But anyway, try to understand the concept now. Fine. So now, uh, yes. So now let us start with the today's session. And okay, yeah. One more thing, like big O notation, we did more thing, you know. We saw something like we saw also multiple examples with this big O notation. We saw multiple examples with this. We also did. We also no clarify the general rules of this. If you see the doubt session, in that also I discussed about the general rules for the big O notation. I'll also discuss this right now. So those who haven't attended that, but I recommend that everyone please attend that. Okay, everyone please watch that. At least I watched that yesterday's class. Okay. Now first rule was that we have to ignore the constants. This does say that, let's say if I have any constants, let's say if I have 2n, then we have to discard this particular constant. Okay, this is what this means. The second thing we saw that about the like complexity chart, you know, I posted the website of this, you know. So order of one would be always greater than log n. It will be always greater than the n complexity. It will be always greater than n log n complexity. It will be always greater than the n square. Then we have 2 raised to n, and in the last we have n factorial. Okay, this is what the uh, the hierarchy of the which is depend on which depends on the more complexity and which is contributing the lower complexity. So if I say that if your time complexity is something like this, that n log n plus n to the square. Okay, so in this particular chart, which is more, n square na? So you have to ignore this term, lower order terms. This is what I can say. Lower order term you have to ignore, and you have to consider this. Yes or no? है ना? This is what we also saw yesterday. Now, in the previous class also we discussed about the in detail this. है ना? So now we have to ignore the lower terms. That is what we have seen right now, है ना? Now if I'll say that suppose if you have a sequential statements, na? Suppose if you have a sequential statement, like you have a multiple statements like this. Let's say my first statement will look like something this, second statement will look like something this. Now in this first statement it will contribute to my n complexity, and in my second statement it will contribute to my 2 raised to n complexity. Now since this both the statements are sequential, we have to add both of them. Yes or no? You remember that? है ना? है ना? Everyone? ठीक है? So it will be basically what? It will be basically n plus 2 raised to n. Now, if you see in this particular chart, which is more, n or 2 raised to n? Obviously, my more thing is what? 2 raised to n, right? So this will be my ultimate answer. It will be, this will be discard, n will be discard, and 2 raised to n would be my answer. Yes or no? है ना? We saw that. Okay, Nishant, you understood now? Little bit. Okay. Okay. Uh, okay. Now we also saw that if we have a nested loop, then we have to multiply both of the thing. Let's say if I'll be having like this is my first thing, this is my second thing. This both are nested, right? This is contributing my n, this is also contributing my n. So this both the thing would be multiplied all together, and it will be n into n. That would be nothing but your n squared complexity. You remember that? Do you remember that? Anna? Okay. Now the other thing we saw that is, let's say if I'll be having problem, let's say if I give you a problem, let's okay. So see, every big O complexity, okay, if I'll talk about the big O complexity, then this will be, can I say, this big O complexity will be depend on your algorithm's input size. It will be directly proportional to your computer steps, you know. Yes or no? So let's say if my input size is 5 and my computer steps are let's say uh, 20, and in 5 input steps are let's say 20, and let's say here is 10 and my computer steps are 40. So can you see relation in between the both of them? What is the relation? What is the relation between both of this? 2n, है ना? Great. Okay, so it will be 2 into n, but since my 2 is my constant, can I ignore that? And can I say my final answer would be this? It's my O raised to n, sorry, O to the power n, not power, like O of n. Yes or no? Right. Okay. Now now let's say, let me start with something different now. Okay, this all we have seen in the previous classes. We have also covered some of the very basic concepts, you know. But let's say if I have some program like this, let me take uh, let's say, just a second, I'll be sharing my VS Code screen. Let me know once you guys can able to see that. Okay, you all can see it. You all can see it, my Visual Studio screen, Visual Studio Code. Yes or no? है ना? ठीक है, चलो. So now here, suppose I'll say that if my problem statement is something like this, let's say my problem statement will look like something like this, that you have been uh, given an array, and in that, suppose you need to uh, find the element in the array. Okay, element in the array. This is what your problem statement, है ना? And you need to return true if in case the element is present, and you need to return false if it's not. Okay, so this is what your problem statement is. Let's say my array is 1 2 3 uh 3 4 5 and 6. Okay, this is what my array is. And if my element to be find is, if I'll say that my n is something like 4. Okay, if my n is 4, then you need to return me true in that case. Okay, and since my 4 is present, you need to return true. And similarly, if I have my array like this, okay, and if my element is still 4, then I need to return false. Can you all guys can write the program of this? Can everyone here can write the program of this? Just a second. I'll be doing it as 2006. Uh, make analysis, and I'll store it as guys. You can start your work. You can start your work. Okay, I'm just doing something else. I'm finding something else. Okay. Okay, you can see the screen now, and you all guys can see the screen. And can you guys can start work accordingly? Okay, I'm giving you some time to write the code. Please write the code. Please start writing the code. Just a second. I think something went wrong. Yeah, this is the thing. You can use anything you want. Okay, there is nothing the thing that you have to use this, you have to use this. There is nothing like this. Okay, you can use anything you want, but just try to complete this one. How many of you are done and how many of you are trying still? I can see some comments. They did this working. Okay, please complete it fast because it's very simple thing. Okay, Ravina, please try. Okay, ठीक है, चलो. This was very simple thing. So what I can do here, let's say if I'll initialize my function, let's say search element, है ना? This kind of function I can initialize. Inside this, I can take my list and I can take my element. Yes or no? है ना? Okay. Just a second. I think I have stopped that. Okay. Can you see now? Can you see the screen now? है ना? Can I do this? ठीक है, I will accept a list and I'll accept my element. ठीक है, and inside my function, what I can do, I'll just I'll just iterate through it. Okay, I'll simply iterate through it. Let's say I'll just do my I equals to 0. I should be less than whatever my list is, list dot length. I'll do that. Okay, fine, I'll do this. I plus plus. Inside this, I'll just check whether my current element, that is what my list of I, is equals to my element or not. So no. And if yes, then I'll just return true. And if after all the scanning part of this particular thing, if I'm not able to find my answer, then what I'll do, I'll just return false, because I have just completed my every iteration and I'm not able to find it. So I'll just return false. If I can able to find, then it will anyway return from this. It will not execute this. Yes or no? Everyone should be clear with this one, right? Now, okay, fine. So if I just want to find the time complexity of this, if I want to find the time complexity of this, what should be the time complexity of this? In my worst case, okay, I'm asking about the worst scenario. What it could be? Everyone. So, see how this is a worst case, right? So, see, right now, if I want to talk about this order of, it will be order of n clearly, right? Because if my list of element, it is just executing this only, right? So, this iterating that how many computer steps would be there? N steps. So, can it's clearly order of n, right? But if I just everyone is knowing this, yes or no? Everyone knows this. Any doubt in this particular thing? Okay. So now, good. So if you have this particular thing, then if I'll say how this is my worst case, so if I say that currently in my class, let's say I have 36 students. Okay. Now I just want to find a student whose name is Mehak. है ना? ठीक है? So if I'll give this particular task to you, what you will do? You will go to each and every student and ask their name. You will keep them asking until you will find the name Mehak, है ना? Now इसमें multiple scenarios can happen, है ना? इसमें multiple scenarios can happen. Can I say that in the worst case scenario, is the last person that I ask whose name is Mehak, है ना? Every person I have scanned, every person I have asked, and if I ask 36 student, his or her name is Mehak, right? So I have to ask everyone, so then I found the actual name, है ना? So that is my worst case, isn't it? Huh? Yes or no? Because I have to ask each and everyone, then I able to find it. Now, इसमें tell me what would be my best case in this? What what should be my best case in this? Okay, so my best case would be what? That uh, like if I'll ask my first student and his name is what I desired, है ना? Okay. So the first student had the name what I wanted. So that is what my base case. So in that best case, how many computer steps I would take? I would no, I'll do one only, है ना? ठीक है? So can I say in that particular case, my best case complexity of this particular thing would be omega of 1, because I said that best case would be always right in terms of omega. Worst case would be right in the terms of big O. है ना? Yes or no? ठीक है? So the worst case is that like total number of computer steps that we have taken, that was order of n in case of worst case. In the best case, my first student's name was there what I wanted, so I just did one computer operation only. So can't I say that it will be omega of 1? Everyone should be no, everyone should be getting this, है ना? So my best case here, so this is what the same case, na? This is what the like similar kind of thing. I just wanted to find this element. So can I say if I just wanted, like if I found this element at first, this will be my omega of 1. I cannot write omega here. I cannot symbolize it. So right now I'll just writing it like this. Yes or no? है ना? ठीक है? Now, if I want to talk about the average case of it, now, so there were 20 students in my class. So let's take an average of it. Okay, let's take the average of it. Let's say after 10 students in my 20 student class, in the middle of somewhere, I found the name Mehak. है ना? So total were 20, and I found in 10th or 11th student that particular name. Okay, so basically, can I say that? See, can I say like this that I had 20 students, and in that particular thing, I found my, let's say I had currently I have 30 students. Okay, let's say I found my element or my student in 14th or 15th student. Okay, okay, okay. So in that particular thing, can I say that if my n is equals to 30, I did like I found my student in 14th or 15th step. So can I say my computer steps would be like this 14 and 15 would be anyway equal, like they are both like next to each other, right? So I'll say that there are like 15. I did 15 on an average, है ना? So this will be what, this will be what, n by 2 steps. This is nothing but my n by 2 steps. Huh? Yes or no? Okay, so n by 2 means nothing but what, like n by 2 is what, 1 by 2 into n. So can I ignore the 1 by 2 here? So can I say it will be order of n? Yes or no? ना? ठीक है. So now see here that I'll explain once again everything. Okay, I'll explain the average case once again. See, if I want to talk about the average case here, let's say, okay, let's say I had 30 students in my class. Okay, out of this 30 students, I'll just find, I'll just ask my first student whether her name is Meg or not. Second, her name is Meg or not. Third, up to 15 students. Okay, after this 14th student, after this 14th student, I found what I wanted in my 15th or 14th, है ना? Anything up like anything in the 14th or 15th. Okay, okay. So I found this particular person in n by doing n by 2 steps. Okay, but 1 by 2 is constant, so can I ignore that? And my answer would be anyway n. Yes or no? Everyone should be clear with this particular thing. है ना? Clear है? Okay. Now, this average case is denoted by, I talked about that. The average case is denoted by theta. You know, theta of n would be my average case complexity. Clear? है? Okay. Okay. Now, now, if I say that, so everyone is clear up to this. Everyone is clear up to this. Okay. Okay. Nishant, The best case is what, like if I'll say in another thing, let's say if you have a particular product of mrp rupees 10. So if you found that particular product in just 1 rupee, can I say that that would be the best case of it, you know? Like there are some product which is sold in like in Maharashtra it is sold at 20 rupee, and in Bangalore it is sold at 25 or 30 rupee, but its mrp is way higher, like 40 rupee. So if you are getting it the product at 20 rupee, can I say that it is nothing but your average case? And if you get that particular product at much lower price in any part of India, so then can I say it will be your best case, you know? Okay. So the worst case is denoted by omega. The best case is denoted by what? Best case is denoted by omega. Worst case is denoted by big O. Yes. And average case would be denoted by what? Theta. Right? Okay. Clear है? Okay. Fine. Chalo. So let's say if I'll take one more example. If I'll take one more example of this, let me go with my board only because just a second. Okay, so now your question is that let's say mm, 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 let me think. Okay, let's say if you have this particular function, okay, let's just a second. If you have a particular this function foo, okay, in that particular thing you will be having your n, and inside that you are having your let answer is equals to 0, and you are having your for let I is equals to 1, I should be less than uh, n and I plus plus. Okay, you are having something like this, and inside that you are having another loop. Let's say let j is equals to 1, j should be less than n, j plus plus. Inside that you are having let's say answer plus equals to 1. Okay, and I'm just changing a little bit. Let's say instead of n, because we did the n, so what I'll do, instead of n I'll just do math dot log of n j plus plus. Okay, like this. So I think so I should write the code, है ना? Because I don't think so you will be comfortable in my writing. Yes or no? So anyway, we'll keep this particular question here right now, and after this I'll write. Okay. Okay. So you need to tell me the time complexity of this. You need to tell me the time complexity of this. Everyone. Okay. Okay. Just a second. I'll ask. Uh, Nobody will comment here. Nobody will comment here. Okay. Nobody will comment the right answer here. I the person whom I will ask, that person only should answer. Okay. So let me see how many people is there. How many people are there here? Okay. Okay, just a second. Uh, uh, uh. Okay, Bharat, are you there? Bharat, you are in class. Okay. So you need to answer this particular question. Okay. You can take any amount of time, but not that much of big. Okay. You need to think about it and you need to give me the answer. This is very simple thing. Okay. I will be waiting for your answer, and nobody will comment the correct answer. Okay. Until I'll say. Okay, and yeah, one more thing, just for your information is this, like, see, whenever we do math dot log, then the persons who have, no, understand about the logarithmic thing and mathematical thing, they have learned about this in the 10th standard. Now, though for those who have forgotten this particular thing in their memory, then whenever we are doing this math dot log of x, it will be nothing but the ln of x, na? It will be ln of x, and if you want to convert it into the base of e, like it will be the base of e anyway, you know? So you don't have to worry about the base here. Now you just need to take care about the like complexity of in terms of order of something. Okay, you need not to worry about the base. Okay, just for your information. Now, just tell me, think about it, and let me know the answer. Yes, Nilanjan, these are the notations of like different kind of things. Like if we say about the worst case, then it will be big O. If it's like best case, it will be what? In the best case, everyone, omega. And in case of average case, it will be what? Theta. Okay, it is the notation of this. Okay, so whenever I'm writing this theta of something, you have to understand that this is my average case. Okay, now think about everyone, think about this everyone, and let me know the answer. Just a second. Chalo, Bharat, you are done. Are you done? Okay, order of n log n. Okay, okay, everyone can answer now. Okay, I want answer from everyone. Okay, so those who have answered the n log n, those people are correct. Okay, those who haven't, let me share what is the logic behind it. Okay, so let's say if I have this particular loop, है ना? If I have this particular loop, then can I say it will be the order of n complexity? There are n particular steps, there are n computer steps, है ना? So there will be n computer steps of this, है ना? Now, now for every n step, for every n computer steps, can I say this will be added? Yes or no? For every computer, for every n steps, this will be added. Na? So how many times you are doing it? Log n times? How many times you are doing it? Log n times? Na? So you're doing it particular thing log n times. Okay? Okay? So in that particular thing here you had n steps, n computer steps. Here you have log n computer steps. Okay? Now okay, someone will ask how many, like how come it will be the log n, है ना? So suppose मान लो कि in this particular loop if you have one, like if you have first iteration, ठीक है? So what you will do, the log of 1. For the second step it will be log of 2. For the third step it will be log of 3, up to n it will be log of n. Yes or no? है ना? ठीक है? So it will be for n step, for n computer steps, can I say it will be my log of n? So how many times you are doing this log n operation? How many times you are doing it? For every operation of this, for every value of this I, you are doing this much of operations. Okay, you are doing this much of operations for every value of, for every value of this I. So can't I say that it will be nothing but your n computer steps into your log n computer steps? So it will be nothing but what? N log n. Can I say that, people? How many of you are clear? How many of you are clear? Clear है ना? चलो ठीक है, चलो great. Now uh okay, ठीक है, चलो let me take another example. Can I take another example, है ना? Can I take another example? N log n is the worst case. Yes, n log n is the worst case. Now, as I have already told you, na, that see, the best case and average case, nobody will ask you about this. है ना? In the in the exam also, I don't think so. They will ask about it. But if they will, you have to know about it. Okay, that is why I taught you about this. Now, don't worry. We'll also cover some more example with respect to that, okay, but not much in case of best case and worst case. Like best case and average case will be just focus about the this worst case only, because everyone will be asked about this. Okay. In the next week also, like in this week also, we will be covering about the sorting algorithms. You know, there are many kind of sorting algorithm also. So in that particular thing, you can also, you have to find the best case, worst case, and average case. Okay. In that also, you will be doing the same thing once again. Okay, so don't worry about this. So okay, so there any pattern average case, yeah, I'll come to that. Okay, I'll come to that, don't worry. Okay, I'll come into this. Let me take another example meanwhile. Now, okay, let's say I have my function foo. I have my n into m, n and m. In this particular thing, I have let a is equals to 0. I have for I is equals to 1. I should be less than n and I plus plus. Fine. Inside this, I have something like for j equals to 1. And now I have, let's say, not inside this. Let me take not inside this because we have covered lots of thing inside this. So let me put it like a plus equals to I. And let me take after this. Okay. So after this, let's say I'll initialize one more variable at b equals to 0, or else I'll just take it here, b equals to 0. Here I'll just take for j equals to 1. J should be less than m. Please note here, people, whatever I'm writing, please note carefully. Here it was n. Here we have m, and b plus equals to I. Okay. Now you guys have to tell me the time complexity of this. You need to tell me the time complexity of this in the big O notation. Again, nobody will comment. Nobody will comment. Oh, you did the comment. Okay, fine. Chalo. इस question के लिए no worries. Okay, so everyone will answer about this. I will be waiting about everyone's answer. Okay, I want everyone's answer, not just 2 to 3 or 10 to 15 random people. I want everyone's answer. Just there is not the this case that best case will always be one, but I'll come into that. Okay, don't worry. Ikta, we will be covering lots of problems also. We'll be also starting with something else also. This please wait for a while. Okay. Okay. So now I can say I have very minimum comment. I want everyone's comment. If you if you have the answer, please comment it. If you don't have answer, comment that I don't know. And if you want me to repeat the question, comment that I don't understand the question. Otherwise, ask the random people. Okay, I'll ask random people, and I have a keep. I'll keep the note of it. Those who are not able to participate in the class. Okay, Yunus, can I know the reason why you don't know about this? Can you unmute yourself? Can you please raise your hand? I'll unmute you. There is no shame to ask, or there is no shame to repeat, like ask me to repeat. Okay, that is perfectly fine. Everything is perfectly fine. Can you raise your hand, Yunus? I said that. Okay, chalo, no problem. Fine. Chalo, let's start with this. Let's start with this. Let's say we have this function, okay, foo n and m. Okay. Now, first of all, let me tell you, for those who have answered n plus m, they are correct. Anything else apart from this, it's not correct. Okay. Okay. Wait a minute. I think so. Yunus have raised his hand. Yes, please tell me, Yunus, what is your problem with this particular thing? If I'm audible to you,
Yeah, hello sir.
am I audible to you, Yunus? Am I audible for everyone else?
Sir, I'm audible.
Yeah, yeah, you're audible. Yes, Yunus,
Hello,
please. Yeah, yeah. Am I audible to you? Hello. Am I audible to you?
hello, sir. I'm audible.
You are audible. You are audible.
Sorry, sir, I can't hear you.
Okay, you
I'm
can drop.
audible, sir?
You are audible, but I think so you are not able to listen my voice. That's perfectly fine. You can drop. Okay. So Yunus, I was able to listen to you, but I think so you were not able to listen to me. I will be explaining once again what I mean to say about this. Let's say I have this particular function. Let's say I have this particular function foo. I have two arguments n and m, right? So as I have said that whenever you have sequential, these are the sequential thing. Yes or no, everyone? So any complexity, let's say if this complexity is my x, this is my y. Can I say this will be both will be added? This is clear, Yunus? To you also this is clear? Whenever we have sequential statements, we will be adding that. Yes or no? Okay. So let's say let's just find the complexity of this. So let's say, can I say that this for this particular loop, my complexity is order of n? Yes or no? है ना? For this, can I say my complexity is order of m? For up to this particular task, I think so everyone was correct. है ना? Suraj, why no? Because this is m na, so this will be okay, fine, mistake na, fine. So can I say this both will be added, है ना? So can I say it will be order of n plus order of m? Yes or no? Session, why it's no? It will be added na, because these both are sequential, as I just said 2 minutes ago, right? So can't I just add this particular two things like order of n plus m? Now many of you will tell me that, sir, this is n, this is m, so why can't it be order of n or order of m, है ना? There will be two different things like order of n. Many guys will say order of m. Yes or no? Right? But did I tell any point of time, that my n is bigger or m is bigger? If I'll say that my n is bigger or m is bigger, let's say if I consider that, I'll say here that n is greater than m. So my this m would be anyway ignored because n is more. Yes or no? So in that particular case, you can ignore this. But I didn't tell anything that my n is greater than m or not. Okay. So you don't have to assume anything by your own. Okay. You don't have to assume anything by your own. Again, do not make any unnecessary assumptions about the variable values. We do not know anything about how n and m are related. So we need to make any assumption on it. We need not to make any assumption on it. Okay. Fine. So we see that this is my independent loop and its complexity is n. Yes or no? This is also my independent loop. Its complexity is order of m. Yes or no, people? है ना? So again, this is my independent loop. So this both are will be added since this will be my sequential statements, right? And I did not tell you that my m is greater than n or my n is greater than m or my n is equals to m. I did not tell any of this relation between n and m. So why you were asking me, like why you were giving me answer of in terms of n or m? It will be in the both of the way. Am I clear? Am I clear, everyone? Yes, if it will be nested, then it will be order of n into m. Correct. Okay. Dipanshu, you got this? Well, Dipanshu got this na? ठीक है. Yunus, you got this? ठीक है, चलो, great. So you can answer the next question. Will you answer the next question, Yunus? Yes or no? I'll ask the question. Will you ask that particular question? Do you want to attempt that? Okay. ठीक है, चलो, great. So, uh, okay. Let's say here I'll say, let's say here I was saying that, let's say here I'll say that my m is equals to 2n in this particular question I'm talking about. Okay, I was talking about this relation na. So I will tell you that Right now my m is equals to 2n. Now tell me the complexity of this. Now tell me the complexity of the same question. What will be my complexity if my m is equals to 2n? Guys, why you are thinking? Is crystal clear? Ekta, why it's order of m? Okay, okay, just a second, just a second, just a second, just a second. So, can I say like my n is equals to like n plus m will be this, right? So can I put my in place of m? Can I put 2n? You know? So in the case of like if you have this particular answer na, if you have a choice to answer in n or m, always choose n only, not m. Okay, Ekta, fine. Okay, so here I'll say n plus m is what? 2 into n raised to n. So it will be what? Order of 3 into n. 3 will be ignored since it is constant. So can I say it will be order of n? Nishant, you are clear? Okay, chalo, chalo. Next question. Next question would be something like uh, let's say okay, okay, chalo. And yeah, one more thing here to note is uh, see in 80% of examples the best case would be order of 1. Okay, and in the average case will be equals to worst case. Now how I'm talking about this, let's say in my previous example, let's say in my previous example which was the log n times, right, which was this example. Now in this particular example, if I just want to find out my best case and average case, what we will do? See, can I say that in my best case scenario, can I say that I just need to iterate one step only? Because if I'll say that my n will be 1, so I will be just doing the one operation only, na? I'll not do anything else. Let's say here I'll just do one operation. I'll not go till n in my best case. Yes or no? है ना? Right? Okay. So can I say that my best case here would be order of 1, right? And if I'll say about the average case, so yeah, see, for I equals to 1, the number of steps are 1. Why? है ना? Right? Because log 1 is nothing but 0. Correct? See, I said that. Let me remove this one. Let me remove this one. So can I say here that for I equals to 1, for this particular I equals to 1, I'm talking about, okay, the number of steps are 1. Yes or no? The number of steps would be 1 only. है ना? So can I say that my log 1 is anyway, but no, my log 1 is what? 0 only. How many of you are clear with this? And yeah, let's say I don't have here n, I have I. Okay, I have I, not n, because in if I have n, then it will be anything else. Okay, if I have I here, okay, Mac, I'll explain it again. So let's say if I have I equals to 1 here, okay. Okay, so for first step, can I say this mat.log of I will be executed? It is nothing but what? 0. Log 1 is 0. Those who don't know, guys, you're clear, है ना? So in that particular case, there will be only one step, है ना? Yeah, that won't be executed. Like yeah, that won't be executed here, है ना? So that will be 0 steps. So it will be what? My best case scenario. Yes or no? है ना? I hope this is clear to everyone. So yeah, if I'll repeat that, if I have to repeat that, though for those who haven't understand this, who so for those who have not got this particular thing, then see what was in my question. What was in my question? The question asks that my let's say if I start with I equals to 0, then what? If I'll start with I equals to not 1, I start with I equals to 0. Then how many steps it will iterate? How many steps it will iterate? One, one or two. Think about it. Think about it. How many steps it will iterate? See, see, for I equals to 0, for I equals to 0, can I say here that for my I equals to 1, the number of steps would be 1, right? Why? Because log 1 is nothing but 0, correct? So wahan par you are doing iteration, and in the first step itself you got the answer, right? So order of 1 will be your answer. Yes or no? है ना? Everyone should be agree with this. Everyone should be agree with this. Yunus, Ravina, Dipanshu, everyone is agreeing with me. Don't just say random yes. Okay, Deepak, I'm explaining once again. Okay, so what I did that I have my I equals to 0 here. है ना? So I'll just do my iteration. Okay, let me copy this. Let me copy this one and let me go here. Let's say I have this. Okay, now what I'll do here that for this I equals to 1 I'm executing right now. So right now my this is my I, this is my j. My I is what? 0. Okay, 0 is less than whatever my n will be. Let's say my n equals to 5. Let's say, okay, 0 is less than 5. Now inside this j equals to 1, right? So I j will be starting with 1. It will be execute till what? Math dot log of I. So can I say that it will be what? Nothing but math dot log of 1. But log of 1 is what? 0. So it will be anyway it will be 0. So my here how many step it has taken? 1 is less than 0, है ना? For this step only, and it will be left off from this. So can I say this will be my best case scenario, since it has just done my one iteration only? Deepak, am I correct? है ना? Okay, Deepanshu says I think whole scenario the time computer will be all out of n because in inner loop. uh Dipanshu, I'm talking about the best case scenario, not the worst case scenario here. Okay, and Dipanshu, for every other case, like if you can take about I equals to 2, then do it. Like 1 is no log of 1. Okay, so it will be every anyway left off, but it has executed na, it did the step for n times. Yes or no? Vishal, we have I equals to 0 here and j equals to 1 here. That is why we have taken 0 and 1. Okay, Vishal? So here my best case would be order of 1. Okay, not order, it will be what? Omega or theta, omega of 1. Now if I want to talk about the average case. Okay, so in case of average case, what would be a logic? So in case of average case, the logic will remain the same as, let's say I'm doing the half operations. Okay, I'm doing the half operations. So in total how many operation I'll do? In total how many operation I'll do in case of the average case? Everyone. Okay, so that my uh, can I say that I'll take n log n by 2 operations here? Na? Okay. Why? Because see what was my question? You guys are still not getting. You guys are still not getting it. Okay. Let me explain everything. You guys are still not getting it. Why? I don't know. Anything. Anyway, let me explain this once again. Okay. Don't worry. Now, can I say that this is having my n operation? This is having my log n operation. This is clear. So it my worst case would be n log n. You know. Now, in case of my best case, this is what my question is. Okay. So in case of best case, I'll start with zero. So can I say, like, in best case, you have to think about the very optimistic. Okay. You don't have to think about worst case scenario because you have already thought about it. Okay. So in best case, can I say in my first iteration only I got my answer? You know? So it will be what omega of one. Now, if I'm talking about the average case of it, okay, then can I say I am getting my answer in middle of something? Okay, so can I say it will be my n into log n by 2? You know? Yes or no? Okay, so this 1 by 2 will be anyway ignored. So it will be nothing but what? N log n, right? Yes or no? Yes or no, people? No, Mac, every time it will not be omega of 1. We will cover some scenario where it will be not be the 1. Okay. So you have to wait for some time. But but if I will talk about, sir, even for best case, this will be one time will be ignored. Yeah, we have ignored, but we just have one na. We do not have 1 into n. If we could have 1 into n, then we can ignore this one, but right now we just have one. So if you see in this particular thing, see here, what is minimal thing? One na. So if you have something to compare like 1 into n or 1 into n square or anything apart from this one or constant thing, then you can ignore this one because you have bigger thing. But here you don't have any bigger thing, you just have one, so you cannot omit it. Okay. Average case, like, yeah, I'm telling about that only. So remember guys, like, if you will also note about this. Okay, so in 80 percentage of examples, in 80%, or I'll say 90% of examples, what, like, your best case will be always be omega of 1, and your average case equals to equals to your worst case. Okay, you will observe that this is not the thing that you have to remember, you will derive these things. Okay, we will be covering in this particular week only, we will be covering many sorting algorithms. Let's say selection sort or bubble sort, insertion sort. There are many algorithms like this. Okay, in each and every algorithm we will be considering, we will be calculating best, average and worst case scenarios. Okay, but you don't have to worry about it much. Okay, everyone will be bothered about this only. Okay, they will rarely ask, they will not ask, I'll not say, but they will rarely ask about this. Okay, that is why I'm not putting detail into that again and again. Okay, I have also observed with many organizations also, they will not ask it. Okay, you can also confirm with this particular thing in many resources also, you will also read this. Okay, अब यहाँ से ना we will increase our level, so make sure you tighten your grip and doing. Okay, so we have done a lot of basic questions. From now onwards we will cover the advanced questions. Okay, so let me take the doubts, just a second. What about inner loop in its average case for combining with outer loop? Dipanshu, let just a second. Don't do not be like, can't we cover this thing here only? This was the inner loop only, है ना? This was outer loop. This was my inner loop, है ना? So here you have to consider that you are getting answer in between of something. You are not getting answer in last. You are not getting answer in first. You are in between. It's just like a flight example, है ना? So in that case, they will tell that your flight will be delayed at max by 5 hours, but every time your flight are delayed by 2.5 hours, है ना? It's not on time, it's not 5 hours late, it's not 6 hours late, it's like in between of something. Okay, so you have to think about logically this thing. Think about the case in case of best, average and worst. Okay, okay. Math.log, how come n log n by 2? uh See, Hariharan, can I say that in the worst case I'll iterate everything here? So in that worst case, this will be my n step, this will be my log n step. So can I say it will be my n into log n steps, Hariharan? In the worst case, can't I say that it will be my n into log n steps? Now So can I say that in my average case, my steps would be half? Let's say if I'm taking here 50 steps, can I say I'm taking just 25 steps and I'm getting my answer in average case? So that is what I did. N log n by 2. That is what I did. But math dot log n of I. Okay. So what? So yeah, like what do you mean to say here? I'm not getting it. So you mean to say that like every time my I would be zero? That's what you mean to say? That's what you mean to say? Math dot log of n. It's I. It's not n. Okay. So yeah, I'll repeat once again. Okay, I'll repeat once again. So can I say that? Can I say like this that for math dot log n wala loop है ना ये वाला inner loop. So for this, can I say that for the first iteration, let's say for the first computer steps, I'm doing log of 1. For second computer steps, I'm doing log of 2. For third computer steps, I'm doing log of 3. Can I say that? Okay, up to n computer steps, can I do it? Log of n? Yes or no? So it will be run for how many times? Log of n times? Like your rationale here is true. Your rationale here is true that sir, my I is 1 here. So anyway, it will be not going into it. But every time your J plus plus is doing na, you are doing a J plus plus, है ना? So your loop is anyway running. Now inside that, if you are going into this or not, that doesn't matter because this is my constant operation. Yes or no? This will be my constant operation, है ना? So yeah, that is the thing. Now now let's say I'll take, yeah, from this I was saying that we will not focus on basic questions from now because we have covered a lot of basic questions. Now give me the answer, the only person I'll ask. Okay, okay, am I making sense, people? Okay, so I was telling that yahan se the level will be increased, so make sure you will focus on it, है ना? We have done a lot of basic questions. If you have any doubt in the basic questions, just ping me out. ठीक है, fine, chalo, let's start. Let's say I have something. Let me think about the question. It was in my mind. Yeah, I think in the first session itself, someone asked me this question, and I explained that. I think that many of you didn't get this, but the person who has asked this got this. That's why I didn't focus on it because I know that this will be anyway covered in this session. Now, what was that question? Let me write it. If you remember it, then just say truth to yourself that you are well connected to the class. If not, then you are not connected to the class. Okay, let me write the question. For j is equals to 0, let's say I equals to 1. From 1 I'll start, and from n, inside this, let's say I'll have j equals to, starting from n, j should be greater than I, j minus minus. Okay, I'm having something like this, and here I'm having answer plus is equals to 1. This is what my thing is, and I'm just consoling out here. I'm just anyway here, I'm just consoling out like print answer. Okay, this is what I'm doing. Okay, so you need to tell me the time complexity of this. Okay, the person I'll ask, that person will only give me the solution of it. Okay, in case of worst case only I'm asking about it. Okay, not the best, not the average. So for this question, Suraj, are you there in the class? So will you answer this? Take your time, but will you answer this? Okay, order of n square. Anyone like guys, you will think about this and give me the answer. Okay, I'll not say right now it's true or not because everyone is trying, but good attempt, very good. Okay, chalo. So for those guys who have answered order of n square, they are correct. Okay, so now let me tell you how. So see, it's always best to find computer steps first and give the answer. Okay, you need to find the first computer steps and then you are supposed to give the answer. So let's say if I is equals to 1, you know, so let's say I have very small space here. Let's say my I is equals to 1 here. Okay, for I is equals to 1, I'm doing it. Okay, so then can I say that I will start from j equals to n till the time it will become j equals to 1. Okay, I'll start from j equals to n till the time it will become j equals to 1. Yes or no? है ना? Right? Fine. Now, can I say that I did total of n minus 1 operation here? I did total of n minus 1 operation here. Can I say that? Dipanshu, for just I equals to 1, I am thinking about right now. For I equals to 1, that is j equals to n, right? So j will be what, greater than 1? So it will be only n minus 1 steps here. Yes or no? Right? Okay. Now, after this, suppose my I will be incremented and my I will be gone to 2. Okay? Right? For this particular case, uh, can I say that it will be gone to j equals 2? So total of n minus 2 steps here. Total of n minus 2 steps here. Okay, it will be gone to what, j equals to 2. Total will be n minus 2. Yes or no? No. Now, after this, so it will, can I derive it like this, that can I derive it like this, that for I equals to 1, it will be j equals from j equals to n till the time j equals to 1. For I equals to 2, j will be starting from n till the time j will become 2. Okay, so here it will be n minus 1 step, here it will be n minus 2 steps. So can I say it will be like for I equals to 3, it will be anyway, but what, n minus 3 steps, you know? Can I say it will be go further on and on and on until the time my I will become my n? For this scenario, how it will be good, how it will be doing for j equals to n till the time n, so it will be just execute one time. Can I say that, people? Now, so can I say that it has executed from n minus 1, n minus 2, n minus 3 up to the time it will reach to the 1. है ना? Got it? Now, so in total, what steps I have taken here? If you just calculate it, since they all my were my sequential statement, so it will be what, n minus 1 plus n minus 2 plus n minus 3 plus up to the time 1. Can I say that, yes or no? है ना? So it will be what, my n terms. If you sum it out, it will be my n terms. है ना? So can I say that I'll just common n out of it? I'll just take common n out of it, or else let me think about it. It will be like lengthy process, but okay. Can I say that every constant I can ignore here? Every constant I can ignore here, है ना? So these are n, and this n are running for n times. These are running for n times, for n terms. So can I say it will be my n square? है ना? Okay, okay. So in the interview also, if you think about, if you think about in the interview also, then 80 percentage of what, how you are explaining it, okay, how you are tackling the question, how, what is your concept, what is your logic behind the rational of the problem. 80 percentage of your selection would be based on this, and 7 to 8% would be the code what you are doing, okay. And I can say like, again 7 to 8% would be the time complexity. So this time complexity can make or break your interview. Okay, so telling the time or space complexity will be the deciding factor, and it can make or break your interview. Okay, okay, how, okay, ठीक है, चलो, understood this particular problem? Yes or no, everyone? ठीक है, so the time and space complexity are that much of that, like that critical, that it can really, break or make your interviews. Okay, so okay, fine. So can I say, yeah, can I go further, can I ask another question? And yeah, for this time also, please do not comment here. I'll ask, that person will only comment, okay, then after you will be, you everyone will comment on it. Okay, let me write the question, let me write the question. uh uh, uh let me add first of all pen, black, fine, chalo. So let's say my function, this, I have, for I is equals to 2, then I have I is less than or equals to math dot square root of n and I plus plus. Okay, this is what I have, and I have now n modulo of I is equals to 0. If this is divisible, then it should return false. And apart from this, if after execution all of this, if it's not divisible, then it should return true. Okay, this is what my code is. This is what my code is. You need to find me out time complexity for this in the worst case. Now for this question, who will answer? Navneet, are you there? Navneet, you in the class? You'll be comfortable to answer? Okay, chalo. So think about it carefully, calculate the steps, then answer the question. Okay, it is very easy to answer. Okay, everyone else also, please calculate the computer steps, then answer. I can also answer, like I can also ask the random people. Great, Navneet. That's correct answer. Awesome. Everyone agrees with Navneet, है ना? चलो, let me explain how. ठीक है? If you calculate the steps here, that I always say that first of all you need to calculate the steps, and I think the answer is very easy and obvious here. We are doing square root of n, so my answer would be anyway square root of n. है ना? So let's say my n is equals to 25. ठीक है? So how many computer steps I'll do here? For I equals to 2, for I equals to 2 I'll do. For I equals to 3, for I equals to 4, I equals to 5. The loop will run till the time, right? है ना? Mat the square root of 25, that is what? 5. ठीक है? So it will run for 2, 3, 4, 5. है ना? For n is equals to 16, how many time it will run? For I equals to 2, for I equals to 3 it will run, and whenever it will be go with the I equals to 4, mat the square root of 16 is what? 4. ठीक है? So till the time it will run. Yes or no? है ना? Why? Okay, ठीक है? Let me explain you, Aryan. Okay. Now, for this, can I say that I did how many operations? Four operations, है ना? And math, the square root of 25 is what? 5. So can I say I did 4 plus 1 operations? Sorry, 5 minus 1 operations, है ना? What is my square root of n minus 1 operation I did? So this minus 1 is what? Negligible, है ना? Because I'm just doing n minus 1, it is nearest number. So can I say I did nothing but 5 operations here? ठीक है? Similar to here, I did how many operations? Square root of 16, that is what? 4. So can I say 4 minus 1 operation I did? ठीक है ना? Yes or no? ठीक है? So it is nearest number. So can I say I did nothing but square root of 16 only? I did operation of this only, है ना? So it is nothing but what? Square root of n. This is how you have to calculate. For calculating the time complexity, you have to consider the computer steps. Okay, as in when it is possible, right? So let me move further. Uh, Now what I can say. So see, these are the constant steps. Okay, let's say I am doing anything inside it or inside this. These are nothing but my constant steps. Okay, so this will be never be calculated. This is clear. This is clear. है ना? Yes or no, people? ठीक है? So yeah, we will take break now. We will take for 15 minutes of break, and we'll come back after 15 minutes. Okay, so it's almost 9, I think so, how much? 27. Okay, so it's 9:27. We will be coming back after 15 minutes. Will it work? Sir, why not log n? Hariharan, what is the relation of log n here? Like what, how you are taking log n considerable here? What is the relation between square root and log n here? Like I'm not getting it. These are like Asman Zameen ka difference hai. What about order of 2n? Ravina, how come? Can you please unmute yourself, Ravina? Can you unmute yourself? Raise your hand, I'll unmute you. Okay, chalo, no problem. And Hariharan, in the base 2, it will behave like square root. See, you remember yesterday we did something like this, let log of 16 base 2. What was the answer? 4. What will be the answer of this 25 base 2? 5. What will be the answer of this, like log of 36 of base 2, 6. ठीक है. So you have to, like, okay, let me tell me the answer of this. What is the answer of this? See, uh if you see now, then you will see that in the first go, if in the first go, you will see that order of square root, like square root of n and log to the power, like log n to the base 2, they are equal. But in the complexities, they are not equivalent actually. How come? Because square root of n will increase a lot of, like a lot more quickly, you know, it will increase a lot more quickly than log of n to the base 2. There is no constant c, so that you would not have square root of n. Okay, so that's why square root of n will be less than of log of n. Okay, so you have to consider square root of n only for values n greater than some minimum value. Okay, so there is some easy way to grasp that as well, like we'll cover that when, as and when the no situation comes, but these both are not equal. Okay, so now if I just want to tell you, then I don't know how many of you guys will understand this. Then see, assuming the natural logarithmic number, you have to multiply by a constant. Okay, we have something like n greater than inf. Okay, so we will have that. So you can consider it like this. Let's say I have my log of n, then log of n would be c into square root of n. Okay, this is what it means. Okay, there will be some constant in this square root of n, it will be always come by this. Okay, fine. So if you have understand the concept of limit, if you have studied the limit, then you will probably know about this. Okay, because if you want to compare the functions, then log of n is always upper bounded by square root of n for n greater than 0. Okay, so now if I want to show you, like if you remember yesterday, I sent that particular site, that big o theta, I guess. So let me open that particular thing, big o cheat sheet, है ना, something like this. Let me open that. If you see in that graph also, you see in the that graph also, your order of n and your order of log n, those this both graph are very no unequal, है ना. And in that you don't have any graph of square root, but you can see the order of log n of graph, है ना. Let me post that picture. Let me post that picture here so that I can, you can able to see that. Okay, can you see the picture? Can everyone can see the picture? ठीक है. So see, log of n is very similar to order of 1, है ना. So you can consider that anything of log n, like any other value from other than log n, it will be always bigger than log n. Okay, so square root of n is also one of the example of that, because it will be multiplied by c. Okay, so square root of graph would be something like in middle of this something, but it will not come here, it will not come here, it will not come here, it will be anyway come like this only. Okay, something like that. Am I clear? Okay, you have to always follow this particular no graph. If you have any confusion, like everything will be not present in this particular chart, but you can like idea aa jayega aapko, because you can see here log of 1 graph is like almost similar to 1, है ना. This is my order of 1, and just below, just above that, we have log n. Okay, so anything apart from this order of log n value will be, most of the case will be the bigger value from this. So in this particular case, we are calculating what worst case. Now we are calculating worst case, so we have to consider the bigger value only. Agree? समझ में आ रहा है? Yes or no people? ठीक है, fine. चलो, so can we take break? Can we take break now? ठीक है, so we'll uh, come back at 9:48. Will it fine? Will it be fine people? ठीक है, चलो. I'm audible. Am I audible, people? ठीक है. So, we can say order of n is not equals to f of n, where n is factorial. Like we used to round order of n plus order of n to the where order of n plus order to n to order of n. So, Sadik, basically you are asking me where is the graph of n factorial in the graph pattern. That's what you mean. And you are also telling me that order of like n factorial is the biggest complexity in the all of this. That's what you mean. So, what do you mean? What do you mean to say? I'm not getting it. So let me debug this. What you are trying to say? You are trying to say that order of n is not equals to order of f of n, where this f of n is what n factorial, right? We used to round of order of n plus order of n. Yeah, we do this. ठीक है, order of n plus order of जब भी होगा we round of it till the order of n. ठीक है. Yeah, maximum time complexity will do, where order of 1 plus order of 2n जब भी होगा we'll do that order of n. That's also right. So in the graph where it is order of where it lie, it's greater than order of f of n. Now what does this mean? I'm not getting it. F of n is a function. Yes, it's between order of n and order of f of n. Now f of n could be anything, na? Yeah, yeah. You can raise your hand. Please raise your hand. I'll unmute you. ठीक है, चलो. Am I audible, Satwik?
Sir, you are audible.
Hello.
Hello, sir.
Yeah,
Am I
yeah,
audible?
yeah. You're audible.
Yeah, sir. My question is, sir, like in the previous question, there the time complexity was O of f of n, like the square root function.
O of f of n? No, it was square root of n.
Yeah, yeah. Means I mean that square root means it means O of a function.
Okay,
Means is the
okay,
output we are getting from that function. That is the thing. Uh,
okay. So see,
yes.
this is not a function. This is not a function. You can write it like this: square root of n. This is just the meaning of to write this. Okay, this is not. I have not written this like math dot square root of n. I have not write like this. Okay, you can consider it like this. Only this. This is not a function. This will be a number.
Uh, Uh, okay, sir, or else if we are looping in such that for I equal to 0, I less than a function means there the function returns something else like
This one.
1, 5, 6, like that type of thing. It
Okay.
doesn't give a continuous value, right? So, sir, will that be equal to O of n? Means the time
Okay.
complexity,
Do
yeah.
one thing. Do one thing. You are saying me that for I equals to 1 and I should be less than what?
I less than a means
Any
function
function.
of n, yeah.
Okay.
Function which is dependent on n.
It would be gives it would give me what?
Any means a random
Okay, random
continuous
value.
variable,
Okay,
yeah.
not known value. Okay, okay, fine. Now you are asking me what would be the time complexity of this, right?
Yes, sir. Means initially my confusion what was with the square root because I was assuming that answer will be in the order of n.
Okay. Satvik, see, if you have this values, this question where f of n is not known, okay, as per your terminology, right? So
Means
it would
not
be
known means sir. Actually, I means f of n is known. Actually, I'm not naming any function. It may be
so basically
modulus.
you're telling me that this will be return me some random value, let's say 5, then 1, then 105, this kind of thing, not continuous values.
Yeah, means continuous means like the square root, like 2 or 4. So it is giving somewhat like that a value which we can use for looping.
Okay. Okay. So let's say, can I say that if my f of n is equals to 2n? ठीक है,
Yes, sir.
right? So
Yeah.
if I
Yes.
like f of n is equals to 2n. So if I'll pass 1 into it, if I pass 1 into it, let's say if this is f of I, ठीक है now.
Yes, sir.
So if I pass 1 into it, it will be 2, ठीक है.
Yes, sir.
So can I say this loop will run how many times? Everyone, Satvik, you can say
Two n
how many
times. Yeah.
2n times ना, ठीक है.
Yeah. Yeah.
When 2 can be ignored, it will be run for n times,
N times. Yeah.
ठीक है. Pretty simple,
Yes, sir.
correct? So basically, where whatever your function is, okay, you have to calculate the computer steps for it, है ना? And based on that, you have to put the whatever formulas we have, whatever rules we derived, you have to put that, and you have to derive this particular thing. Am I correct, Satvik?
Yes, sir. Sir,
ठीक है?
but if now, yes, sir.
Okay. What? Please say.
Sir, I was telling that if now in the place of n it is n square, then
Okay. N square. Then it will be n square.
so it
See now.
will go in,
See
yeah,
how many time it will run?
2 square 4 times.
4 times, है ना?
Yeah.
Let's say put the value of 1 here. ठीक है? Put the value of 1 here. For this, put the value of n equals to 1. If you have any confusion, na, take the baby steps and then you will have your answer. Okay? If you have n equals to 1, then you will have what? 2. N equals to 2, it will be what? 8.
Yes, sir.
N equals to 3, it will be what? 18.
Yes, sir.
है ना? Similarly for any everything else, है ना?
Yes, sir.
Right? So if you see, if you derive any formula in between of this, can you derive it?
Sir, the formula is right in front of it. 2n
Yeah,
square.
2n square, है ना? है
Yeah.
ना? So it will be what? 2n square. 2 can be
Yes.
ignored.
Yes, sir. N
Constant.
square.
It will be n square.
Sir,
Correct?
it is. Yes, sir.
है ना? Why it is n square? Because see, if you take n value, है ना? This is like smaller values. If you take larger values of it, ठीक है? So it will be comparatively, it will be anyway 2n square, but obvious thing. But comparatively, you can ignore this thing. So it is negligible thing. So you can consider this as n square. There will be no constant in our time complexities. ठीक है? Making sense?
Yes, sir.
ठीक है ना? Clear है? Any doubt?
Yes, sir. So, sir, basically, if means it is not means this time complexity where their n is not directly related to the function unless and until that n is not multiplied. So, in any case, we are getting a multiplicative impact. Then only the time complexity graph is switching, like from n square, like that type of
Correct,
thing.
correct, correct, correct. Basically, it will be like degree, matter of degree, है ना? Matter of degree. Let's say, suppose if you have like why, if you consider why we are ignoring this order of, like if you have this thing. Yesterday we also we did n square plus n, है ना? So why we are ignoring this? Because compared to this, it is ignorable. It is negligible. That is why we are not considering it. We are just considering it. Making sense, Satvik?
Yes, sir.
है ना? Any doubt?
So, just one thing, that square
Yeah.
root of n that we did.
Okay.
Yeah. So, sir, that will lie between O of n and O of 1.
Between O of n and O of 1. Yeah, correct. Because
So,
see, if you take an example of 25, okay. So O of like 25 will be this n, है ना? So let's say your n is 25. Let's say the graph of 25 is like it will be constant, but think about this like it's not a constant, है ना? It's like order of n. So it be like something like this. And if you consider a square root, then it will be always less than of it. Can I say the square root of a number will be always less than of it?
yes, sir.
Yes or no? So my
Yes,
square root of n would be lie something here, है ना? So n will be always bigger, so it will be below n and greater than 1. ठीक है? It will be something in between of this. Correct?
yes, yes, sir.
ठीक है ना?
Yes, sir. And
Basically
sir,
you don't have to see the graph also. This was just for your understanding purpose. Okay, this is not a perfect graph also, है ना? This was, I just found the this particular link, and we, like every other no, we teach this particular from this graph only, because we have to show you the relation between all of them. Why this n factor is larger? Because its tight upper bound is very large compared to order of 1. There's almost 90 degree of angle.
yes, sir.
Yes, Satvik, you were telling something. Please say.
Sir, actually, I was telling that, sir, where means if there is any constant multiplied with n or any function of the n, in that case only that constant can be neglected. And if any time complexity or any means loop or any action, programming action going beneath it, and the time complexity is less than it, then it can be neglected.
Perfect. Let's say if you have order of 1 plus order of n square, then it can be neglected, है ना? And if you have like this multiplied with something, है ना? This constant, then this can be ignored.
uh,
Do you mean the same, right?
yes sir. Sir, actually I mean that if we are taking order of square root of n and order of n
Order of square root of n and
and
order
order
of
of,
n. Okay, so which is larger?
sir, order of n is larger
Okay,
means
it can be ignored. Simple, है ना?
yeah.
ठीक है? Why?
Yes sir,
Because see why it is ignored. है ना? I'll tell you the reason also. I told you that among these two, can I ignore this?
yes sir.
है ना? Why? Because I told you that always you have to ignore the lower order terms. Now what does this mean, lowered order? Now anyone who had gone through and who have revised that, they will know it, because this will be nothing but n of 1, है ना? n raised to 1,
Yes, sir.
this
Sir,
will be n
this
raised to
this
2.
too clear, sir. Means this concept
Huh.
means
But
I
in
was
case of,
actually
yeah,
confused with the
in
square
case
root
of
thing.
square root of n, what it will be? This is what, n raised to 1 by 2,
Uh,
है ना?
yes, sir.
So
Yes, sir.
compared to this, which is lower, half or 1, half is lower, na?
Yes,
So
sir.
I want to know, I want to show you that. That's why I was showing you this.
Yes,
Making
sir.
sense?
Sorry, sir. Actually, I now I remember you have taught this in class.
है ना? Okay, चलो ठीक है, fine, चलो fine. Okay, you can drop it out, Satvik. Sir, after, can you please explain me what is O N M denotes to? You are asking me about this question. Uh, mm, 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 this question, Yunus. Not this also. I think so. There were n into m complexity, right? This is log. This is, yeah. This one. No, this is also log. Where were this? N into m. Yes, this one. Not this also. This one, है ना? No, sir. What? Not the particular question. So big O. Just a second. Big O, it stands for worst case. N and M is nothing. Like no, nothing is there. Like N, M, and I have used here just for parameters. I think so. You are confusing on this. That's why I'm taking example of this. Can you unmute yourself? I'll explain you. Like this is very basic. I don't know why you are confusing in this. Okay, fine. Let me ask you. Okay, you can speak. Am I audible now? Am I audible? You are not audible.
Hello.
Yeah, you are audible, but am I audible?
Hello. Sorry, sir, I can't hear you.
You can post your question then. I am not able to getting you because you cannot listen to me.
Hello.
Anyone else can listen to Yunus? I can listen to you, but I think so you cannot listen to me. Am I audible? No. Chalo. Yunus, you can post your question, because see, you are asking me that what is the relation between O and an M, and like see, O is nothing but your worst case scenario. You can denote it by that, and N and M is nothing. You know, it's nothing. It's just a variable we have used earlier. ठीक है? Okay. चलो. Can we move further? People, can we move further? ठीक है? Now we are gonna analyze complexity for recurrence relation or we can say divide and conquer operation. Okay. Okay. So far we calculated complexities for iterative code. Correct? Yes or no? है ना? ठीक है? Now we will calculate time complexity for recursion. Time complexity for recursion. ठीक है? Okay. Um, let me complete this. Now, for for this simple, like this is not that much of simple. Okay, this is not the simple work to do. So there are we cannot analyze the complexity of this by simple methods. Okay, that we were used to apply on every other solutions. Okay, so there are different methods for this. Okay, there are different methods for this. First method is something known as what? Substitution method. Okay, the second method is known as master theorem. It is very important. And third thing, that is something known as recursive tree. Okay, or you can also tell like recursive tree. Now out of these three, this two will be learned in the future classes. This thing will be learned today. Okay, this two will be learned when we learn about the divide and conquer, and in it like up like these things. Okay, second and third will be done in the future classes. Now today we will learn substitution method. So what happens in substitution method is, first you need to know the recurrence relation. Now everyone know about recurrence relation, right? We have done a lot of examples in recursion. Everyone should know about what is recurrence relation. Hannah, yes or no? Everyone, I want answer from everyone, not just 5 to 6 people. Okay. Okay, so once you know the recurrence relation, just we need to apply the substitution method and your job is done. So far, whatever problems we have seen, in all of them we just used variables. Yes or no? We just use variables. We did not use any data structure like arrays and objects. We did not use this kind of things, if you observed. Yes or no? है ना? So the space complexity for every problem is order of 1, until and unless you use some data structure to store information, so that the space taken by variables is negligible. Okay, so the space taken by variables is negligible, hence your solution, like your space complexity for every solution that we have discussed so far, is order of 1, and it is not considered like order of 1 is like space complexity of variables, like for variables it is very negligible and it is not considered, है ना? So hence we can say that the space complexity for all questions that we have discussed so far is order of 1, but it will not work in the same way in the world of recursion. Am I correct? ठीक है? Yes or no? You got what I just said? ठीक है? Okay, so on that particular thing, to note now. uh okay, so remember, in recursion the function calls are basically stacking up in the calls. Yes or no? You know, so if I just if I just want to say about the, let's say, recurrence relation. Okay, let's say I'll just say recurrence relation. Okay. Okay, now I think so. Okay, so for iterative it is 1. Yes, Joseph, it is 1. Okay, so for recurrence relation, you have to remember, like we remember, whenever we were doing this recurrence relation, let's say I have some loop, like I have some iterative solution, not iterative, recursive solution, In that I'm calling my function again and again. So can I say first time it will be foo of 1, second time it will be foo of 3, any values like fourth time it will be foo of 4, like this. Everything will be stacked up. है ना? We are using stack for this. Remember, we are using stack data structures for this function calls. है ना? We saw the call stack as well. Okay. Now on that particular thing to note, so the size of stack also needs to be increased when we are using recursion. Can I say when we are using recursion, the size of the stack should also be very more, है ना? Because we are using recursion, we are using the function calls to store in the stack. ना? ठीक है? So let's say, so yeah, when the question is on recursion, it is automatically be sure that the recursion will take some space. ठीक है? So the complexity as well, it will never be order of one as it was used to be in the iterative solution. Am I making sense? How many of you are clear with what I said? Clear है? ठीक है? Okay. So now on that thing particularly to note, now if I'll just ask you a question, let's say you need to print uh, first n natural number. Okay, first n natural number using recursion you need to do. Okay, you need to do it using recursion. Okay, so let's say if I have n is equals to, if something, let's say where it's, okay, let's say if I have n equals to 5. Okay, for n equals to 5, I need to print 1, 2, 3, 4, 5. And for n equals to 2, I need to print the numbers till 2, 1, and 2. This is what is expected. Can you print this quickly with using recursion? Okay, Nana? If I have n equals to 5, then 1 to 5, I need to print. For n equals to 1 to 2 print. Okay? Uh, okay. Aradhya, you are clear now? I just wrote the solution, like I wrote the problem. It's very clear. So everyone, please write it. Okay, done. Everyone, how many of you are still trying? Because it's very simple. It's like kg of recursion. Okay, chalo. Again, we will focus on the three tasks. Again, here, whenever you will heard word recursion, it should be immediately comes into your mind. What? First thing is what? Come on, guys, quickly. The three things for recursion: base case, recursive call, and self work, है ना? These three are my basic pillar of my recursion. ठीक है? Yes or no? ना? Now, now, if I have n is equals to 5, ठीक है? Suppose मान लो if I have n is equals to 5. Now, for this thing, for this thing, I need to print 1, 2, 3, 4, and 5. So can I say that someone will do, someone will print 1 to 4 for me because I'm very lazy? If this task is done, after that I'll be just printing this. Can I say that? है ना? Okay. Now, so for that particular purpose, let's say I'll make a function. Let's say I'll make a function of printing. Okay. So let me write it. Let's say if I have my function print here, it'll pass my n to it. Now, now whatever I have here. Now let's say I want to print 1 to 4 first, and I want to print 5 after that. Okay. 1 to 4 will be done by someone else. So can I say this print of whatever there in my n minus 1 would be print by someone else, and I'll be just printing n after that. Can I say that? Yes or no? Everyone? ठीक है? Now, and the base case is what? Base case can be two things. Okay, base case can be two things here. Like if my n is equals to 0, then I can just return this will be my first base case. Okay, this will be my first one, and second case base case I can also write apart from this, or है ना? This is or thing. You can either you can write this, either you can write this. If my n is equals to 1, then I can console.log n. Can I do that, people? Yes or no? And return after that. ठीक है? Making sense? Everyone making sense now? Perfect. ठीक है? Okay. So either way you can write. Now, if I can talk about the call stack of it, okay? If I just want to talk about the call stack for this, then it will be look like something this. Let's say initially, I have my print of n, okay? Now print of n would be called what? Print of n minus 1. Now this print of n minus will call what? Print of n minus 2. This will be done till the time I am not getting print of 1. Can I say? है ना? ठीक है? है ना? So since the number of function calls, let me write it. Since my number of function calls is equals to value of n. Can I say that here? है ना? Whatever my value of n would be, that many function calls would be there. है ना? So can I say the space complexity is nothing but order of n here? ठीक है? Which is equals to number of function calls in the call stack, which is equals to number of calls in call stack. ठीक है? Yes or no? है ना? So on that note, so here I'm talking about the number of functions. Okay. So if I have n natural number, if I have n natural number, then uh, I have n function calls. Yes or no? In call stack. So it is nothing but it is indicating that my space complexity is nothing but order of n. Okay, when we are doing it iteratively, like when we were doing that the same problem iteratively, let's say if I just want to resolve that particular same thing iteratively, then I'll write something like this: print of n, then for every value of I equals to 1, I should be less than n, I plus plus. Okay, For this I'll do what, uh, print of I. Okay, this is what I do. Yes or no? This is what I do. Enough for iterative solution. So I'll just make comparison here. Let's say want to if I want to cite a recursive solution here versus the iterative solution here. So if I have a recursive solution, then my time complexity will be how much for recursive? N only, है ना? ठीक है, it will be order of n only, and my space complexity will be also order of n because that many functional calls it has taken in the call stack. For iterative solution like this, my time complexity would be still order of n because there will be n times it will be run, है ना? And my space complexity here would be just order of 1 because I am just using one variable only, है ना? Yes or no? ठीक है, one variable also. Or else if you want to understand more clearly, don't understand by variables, okay? Just understand by function calls. How many function calls would be there here? Only one function call. Okay, I'll just write. So see, here I don't write, I need to write console dot log because if I write a print it will be recursive call, है ना? So I just need to call here print of 5. It will do my job. Only one function call. That is why it is what space complexity is what order of 1. Cool. ठीक है, क्लियर है, क्रिस्टल क्लियर एवरीवन? ठीक है, चलो. If this is clear, then I can tell you about that. Okay. So can I say someone will add that particular? Okay, just a second. Okay, fine. Chalo. Let me write one more example. Okay, Dipanshu says will not count. Yeah, it is not a function. Okay, Dipanshu, it is a function, but it will not count that. Okay, Dipanshu, because it is a constant call. है ना? Now let's consider that I have something more detailed thing. Let's say I have a function sum. Inside that I have my list and I have if my I is equals to list dot length minus 1, that will be my last element, then I should return what? List of I. Otherwise I have to call this iteratively. Let result is equals to sum of list and I plus 1. Cool. And I'll just return my result plus whatever my list of I, है ना? ठीक है. Now can I say here that someone will add this elements for me and I'll just add 1 and my job is done, है ना? Or else can I say that here whatever my, let's say here I'll write it. Let's say here this is my time complexity of n. Okay, if I want to calculate it, then can I say that whenever you will do the previous thing n minus 1 plus c in some constant time, I'll do that. Can I say that? How many of you are clear with this? Or what will be the space complexity if we store I the value in the array? Okay, Joseph, what I mean to say that if you have this, particular program, okay, so calculate the time complexity of it. Okay, forget about this, calculate the time complexity of this. So if you want to calculate the time complexity for recursive solution, then what I told you, that first you need to find what? Recurrence relation, है ना? So find the recurrence relation for this for me. Okay, I'm waiting. You need to find the recurrence relation for this. No, you need to find the recurrence relation for this. Basically, let me do this for one time. Okay, basically let me do this for one time. Let me explain you in detail in brief so that you will understand it. So if you have this program, okay, if you have this particular program, then guys, can I say that for finding the sum of n natural numbers, you are recursively making call to n minus 1 elements, you know, for finding the sum of n natural numbers. Okay, for n natural numbers you are recursively call this for n minus 1 elements, because you are doing I plus 1. Yes or no? Okay, है ना? So, and you are also doing some constant operation here, है ना? Because see, you are every time you are adding it, every time you are also adding it. So can I say my recurrence relation for n would be, I will be calling n minus 1 every time plus c for this addition purpose. Can I say this? Can't I say this, people? This will be my recurrence relation. Clear है? Clear है? Everyone? है ना? Now, now, now using this recurrence relation, you need to find the time complexity, है ना? But let me tell you how. Okay, Deepak, I'm repeating myself. Okay, see, can I say if I just want to find n natural numbers, sum of n natural number here, I am recursively calling. I'm recursively calling n minus 1 elements, because every time I'm doing what, I plus 1 elements. Okay, so every time my one element will be decreased, है ना? So I'll be calling this particular thing iterate like recursively for n minus, like every time I'm doing n minus 1 thing, है ना, Deepak? And I'm also doing some constant operation here. So C is for that constant operation. Deepak, am I clear? Okay. So basically, what I just said, that finding the sum of n natural numbers here. Okay, you are recursively. Can I say you are recursively making call again and again and again for n minus one element each time. First of all, you have 5, then you will have 4 element, then you have 3 element, then you have 2 element, then you will have 1 element only, and there will be a base case. Then after you will return. Clear है? है ना? Now, and the constant operation is also clear. Response plus list of I. Okay. So now you, what you need to do using this recursion, using this recurrence relation, you need to find the time complexity. Okay. So how you will able to do that? Let me tell you. uh, let's say I have t of n is equals to t of n minus 1 plus c. I had this. Okay, na? Now what I'll do, I told you that we need to, first of all, we need to find recurrence relation, that we already did. Then we need to apply the substitution method. है ना? So what is that? Let's say in this particular thing, if I have t of n minus 1, so put n equals to n minus 1 here. So can I say n minus 2 plus c would be my t of n minus 1? है ना? Okay. So if I put this here, then can I say t of n would be what? T of n would be what? T of n minus 2 plus c plus c. Yes or no? So this will be my first equation. This will be my second equation. Now I have substituted t of n minus 1 here, है ना? ठीक है? So what I'll do now? Same way I'll find for t of n minus 2. Okay? So if I'll find t of n minus 2 here, then this t of n minus 2 here will be nothing but t of n minus what, minus 4 plus c plus c. Yes or no? है ना? Okay, sorry, it will not be the 4. It will not be the 4. If I put t minus 2 here, if I put t n minus 2 here, then can I say uh by using this formula, okay, put t minus n minus 2 here, can I say it will be t of n minus 3 plus c? Yes or no? Now everyone, if I put this n minus 2 in my first equation, can't I get this? And if I put n minus 2 again here, can I get this? T of n is equals to, let's say if I put this in the above equation, then can I get t of n minus 3 plus c plus c plus c? Yes or no? है ना? Okay. So keeping this thing in mind, basically what we are doing is, so let's say what we currently what we have, okay, we have t of n is equals to t of n minus 1 plus c, t of n minus 1 is equals to, okay, again t of n is equals to, not t of, like this, okay, t of n equals second equation, t of n minus 2 plus 2c, है ना, and this is my third equation. This what, t of n equals to what, t of n minus 3 plus 3c. Can I say that, everyone? Yes or no? Can this thing I can say very confidently, है ना? Clear है? Okay, so basically I got this. And can I say in general, uh in general I'll get this, like if you have every time p of n minus 1, n minus 2, n minus 3, so can I say it will be continued, and t of n would be, let's say at one point of time it will be what, t of I, t of 1 plus nc, yeah. And can I say again that t of n would be here, t of n minus I here, up to 3 will be up to go till I, and it will be ic, है ना? Yes or no, everyone? So basically what I did, n minus 1, n minus 2, n minus 3 up to n minus I, but before that I have 1 also, है ना? ठीक है? So so you have to go till n equals to 1, ठीक है? So I will get this right, है ना? Now, and always remember, always remember, t of 1 would be 0. I'll not say many times to remember anything, but this thing you have to remember. T of 1 would be always 0. Okay? Because time complexity of 1 would be what? Constant thing. है ना? So it will be always 0. Okay? Now, putting this particular fact in our solution, let's say we have in this, okay, so let's say I have an equation of this, t of n is equals to, I had t of 1 plus nc, okay, right? So for this what I did, t of n is equals to, t of 1 is what, 0 plus nc, है ना? Yes or no? ठीक है? So this 0 and c, can I say this as a constant? Huh? So can I neglect it? Can I say t of n will be nc, and the c would be constant, so it will be ignored. It will be order of n. Can I say this? Can I say this particular fact? Okay. So here my t of n would be nothing but order of n. है ना? ठीक है? Now एक बार शांति से देख लो what we did. Do it on your own also, and then we will start something else. Look into it in detail, try to do it on your own, then after we'll move to the something else. Yes, always t of 1 would be 0. Joseph, एक बार देख लो, because इसके बाद I'll give you task to do this. ठीक है? The steps are, first you need to find a recurrence relation. From that you need to apply substitution method to find out the time complexity. ठीक है? Everyone, Aradhya, where you are confused, you tell me. I'll resolve it out. From the third line. Do you mean to like this? This one? Third equation? Okay, I'll explain everything once again. Okay. So this particular thing you are clear? How we find this recurrence relation? Everyone? Suraj and Aradhya, you both clear? Okay. So if you are clear with this, then what I did, instead of this n, I put n minus 1 here. Okay. So if you put n equals to n minus 1 in this particular first equation, what you will get? N minus 2 plus c? Yes or no? है ना? ठीक है. So this will be my second equation. And now, yeah, this n minus 1, if you put again back to t of n, what you will get? T of n minus 2 plus c, because t of n minus 1 will be what? This one. This c, n plus c will be added. It will be become 2c. Yes or no? है ना? Suraj, what I just said, that in that you are clear with this particular two equation, right? So if you put t of n minus 1 again back to this particular equation, what you will get? Put t of n minus 1 equals to this one, you know. So what you will get, instead of this you have to put this t of n minus 2 plus c na. Aradhya, Suraj, okay. So then that's how we got our second equation. Now we'll again find t of n minus 2 putting into this one, okay. So put n equals to n minus 2, okay. So if you put equals to n minus 2 here, you will get what? T of n minus 3 plus c. Okay, again you have to put this n minus 2 equation here. So you will get t of n minus 3 plus c plus 3 plus, that is what, 3. This is my third equation, it will be by 3c. Okay, these are the three equations what we have found, and we know that t of 1 equals to 0. So we'll just put this particular thing now. Yeah, then after we'll continue this up to what? Up to this one. Yeah, this n minus 3 will be gone up to t of n minus I, and before that we have t of I, t of 1. T of 1 would be 0, so we put that into our equation, so it will be 0 plus nc. Now c can be also ignored, so it will be order of n. This is what we did and derived. Okay. Okay, Suraj, Aradhya, anyone else and have any doubt? Why n minus I? Because see, we have n minus 1, n minus 2, n minus 3. So can I say it will be gone till n minus I also? That is how. Okay. Don't we find n minus I using base condition? No, there is no base condition here, because we have found the recurrence relation. So here you don't have to apply these three steps like base condition, self work, and recurrence relation, like recursive call. You don't have to apply it here. Okay. Okay, so now if this thing is clear to you, let me tell you something very interesting. So if you have remember, we did, okay, n minus I equals to 0. No, t of 1 equals to 0, Aradhya. T of 1 is equal to 0. That is what we have printed here, है ना? So see, in this particular equation we put t of 1 equal to 0. This is how we just got nc. C will be ignored because c was constant, so my answer would be what? Order of n. Any doubt? No. Chalo, ठीक है, great. Now, sorry guys, now what we have to do, that we, if you remember, we did a question of Fibonacci using iterative also, using recursive call also, है ना? Yes or no? We remember? Everyone remembers? Now, in that we saw that we'll just write a function, let's say Fibo of n. In that, in that particular thing, we will be doing like n is equals to, like our base condition was this, right? N equals 0, or if my n is equals to 1. Correct? So for this, what we were supposed to do, we just return n for this. Yes or no? है And if not, then what we were doing? We were doing recursive call to our function. That was what? N minus 1 plus fibo of n minus 2. This is what we did. Correct? Okay. So you need to find the recurrence relation for this. So can I say my recurrence relation will nothing but t of n will be, I'm just calling every time this, that t of n minus 1 plus t of n minus 2, and I'm also doing this plus addition operation. That will be what? My constant operation. Yes or no? This will be my recurrence relation. है ना? ठीक है? है ना? Okay. So if this thing is in my recurrence relation, then can I say that for input n, it is nothing but a recursive call to n minus 1 and n minus 2 and a constant operation for adding. Okay. So can I say that t of n minus 1 is nothing but t of n minus 2, because this both are relative term. Remember in square root also we did that, 4 minus, like 4 and 5, this both are very near to near, right? So I can say either this is 4, either this is 4, as per my convenience. This both are next to like equal, है ना, negligible terms. So can I say this both are also negligible terms? So can I say this both are equal? Okay, so difference is just for one iteration. So we can make this assumption that t of n minus 1 is equals to n minus 2. Yes or no? है ना? Right? So keeping that thing in mind, can I say that p of, let's say, n is equals to, if I put uh, n minus 1 equals to n minus 2 here, okay? So what I'll get? T of n minus 1 plus t of n minus 1 plus c. Yes or no? No. So it will nothing but can I, like, can this be rewritten as, rewritten as t of n is equals to, let's say, 2 into t of n minus 1 plus c. Okay, so this is nothing but, can I say that if I put t of n minus 1 here, okay, so n equals to n minus 1, if I put here, so can I say n minus 1 is equals to 2 into n minus 2 plus c? Yes or no? Guys, you are with me? Okay, I'll repeat that. See, I had t of n equals to t of n minus 1 plus t of n minus 2 plus c. That is nothing but t of n minus 1 is equals to t of n minus 2. This is what we derived, right? Now, after this, I put t of n minus 2 is equals to n minus 1 in this equation. So I got this. So I just added this both. So can I say it will be 2 into t of n minus 1 plus c? You know? So I have rewritten this particular statement t of n minus 1, putting n equals to n minus 1. Okay, so if I put n equals to n minus 1 here, can I get t of n minus 1 equals to 2 into t of n minus 2 plus c? Correct, Ankit? Great. चलो, इसके बाद what we can do, we can do something like that. Let me think. uh okay, so इससे भी इजी हो सकता है का शायद. हाँ, ओके, चलो ऐसे भी कर सकते हैं. सो वंस वी गॉट दिस t of n minus 1 is equals to 2 into n minus 2 plus c, we can do something like this, like we had this na, t of n is equals to t of n minus 1 plus t of n minus 2 plus c. We had this originally, है ना, and we put t of n minus, okay, so see, after this 2 into n minus 2 plus c, what I can say, that instead of this t of n minus 2, instead of this t of n, like this thing, if I put this here back, you know, so what I get, 2 into 2 into n minus 2 plus c, plus c. Yes or no? है ना, like this I'll get, I have put this equation here, है ना. ठीक है. So if I have done this operation already, if I do this particular operation here, so I'll get this thing है ना. T of n is equals to 2 into 2 into n minus 2 plus c plus c. Okay, c is nothing but a constant. Okay, so you don't have to worry about it. Okay, you don't have to think much about it. So now this is nothing but what, 4 into, let's say, t of n minus 2, can I say that, and plus 3c, can I say that, yes or no, can I say that people, guys, सो तो नहीं गए ना आप लोग, है ना. So yeah, this is the thing. T of n equals to 4 into 3 of t of n minus 2 plus 3c. Now after this, what I'll do, I'll multiply it further. Okay, I'll multiply it further. Okay, okay, can I say that if this is my t of like t of n is equals to 4 into t of n minus 2 plus 3c, then can I say that it will multi, like, again, if I want to find some step of t of n minus 3, then it will be 8 into t of n minus 3 plus 7c. Huh? If I want to find further, then can I say it will be 16 into t of n minus 4 plus, I think so, 15c. Okay, okay, yes or no, है ना, ठीक है. Oh, okay, Hariharan, you are not getting. So see, this is what my 4 into t of n minus 2 plus 3c, what we have derived for t of n, right? So if you put t of n minus 3 and doing the same iteration again, है ना, so you will get that there is another 2 will be multiplied here, so it will be 2 into 2 into 2. Okay, it will be 8, and similarly the constant will also be get added, and it will be 7c. Similarly for n minus 4, it will be also get added. So can I say, guys, it is nothing but my 2 raised to n or 2 raised to k, can I say 2 raised to k, yeah, 2 raised to k, it is my 16, 8 and 4. Okay, so can I say my k here, it is 4 for this particular line. For this line, my 2 raised to k is what, k is equals to 4, 4, yes or no, है ना. And just a second, just let me complete it first. If this is my 2 raised to k, this is my 2 raised to k, then can I say this is nothing but my n minus k, huh? Because this is what my 4, n minus 4, this is what my k, and this is nothing but 16 minus 1, so can I say it will be my 2 raised to k minus 1, है ना, ठीक है. Now keeping this thing in mind, so there will be a point, can I say there will be a point where n minus k would become 1. Okay, this n minus k would be continue, and this will be 1, t of n minus 1, n minus 2, n minus 3, n minus 4, n minus k, and it will be 1 at one point of time. Na? Okay, so can I say it will be my t of 1, because n minus k what, t of 1, and it will be what here, it will be 2 raised to k again plus 2 raised to k minus 1, and you know that t of 1 is what, 0. Okay, this is nothing but a 0 value. So can I say this will be 0 into 2 raised to k is what, 0 plus 2 raised to k minus 1, yes or no, है ना. So when your this value is 1, so at that particular point of time, can I say that this, whenever your this value is 1, can I say that at that particular point of time, whenever your t is equals to 1, can I say your n minus k is equals to 1, so your k is equals to n minus 1, है ना, ठीक है. Or else can I say my n minus k is equals to 1 here, both of them would be right, है ना, both of them would be right. Okay, so yeah, how I derived that, let me tell you. So let's say if my t of n minus k is equals to t of 1. Okay, so this t would get cut, so n minus k is equals to 1. So yeah, this is what my solution is, and k is equals to n minus 1, this is what my second equation would be. Okay, this both are the equations. Okay, Okay, and if you put this n minus k again here, again here, again back to this, okay, like n minus k, if you put this equation here, you will get what? T of n minus k plus k. N would be cut and T of k would you will get. Na? This thing also you can do. Okay. So basically we got T of 1. If you remember, है ना? Basically we got T of 1 here. If you don't want to get into this, T of 1 you get, it will be what? 0. 0 into 2 raised to k is what? 0 plus 2 raised to k minus 1. ना? ठीक है? ठीक है? Now this 2 raised to, like this minus 1 you can ignore. This minus 1 you can ignore. So you can tell that for Fibonacci series, your answer of this would be 2 raised to k. This is what your answer is. Okay, this is what our long equation, like long process is. Trust me guys, it's not that tough once you are get habitual of it. Okay, first of all you need to find the recurrence relation, then quickly you need to find the substitution method. Yes, k is also a constant, but it's in the raised to, like raised 2 raised to k, right? So you cannot ignore that particular thing because every constant cannot be ignored na? It's 2 raised to k. ठीक है अंकित? ठीक है, देख लो एक बार शांति से. Try to do this on your own, then after we'll stop. कितनों को समझ में आया ये? Yeah, it needs practice, of course. Yeah, and trust me guys, out of this three method whatever we have discussed now, yeah, this one, substitution method, master theorem and recursive tree, out of these three, substitution method are longest one. Okay, this is the like lengthiest one. These two are not that much of lengthy. Okay, so don't worry. But why we need this? Because we need to find recursive solution for no, we find the time complexity for recursive solution. That's why we are doing this. Ekta, you can unmute yourself.
Hello.
Yes, Ekta.
Sir, am I audible?
Yeah, you're audible.
One second, sir. So, here, where did that go? So, did you scroll or something? Because, at one step you did, or you replaced this 2 to the power k with 0. Yeah, yes, sir. Above that last yellow box.
This one,
Yeah.
है ना? Yeah.
Yes,
So
sir.
this t raised to one, the t of one is what? Zero. Zero
Ha,
into
that
anything
one
is
I
what?
got.
Zero.
Yes, sir. So, what about this first 2 to the power k? I know that the second term you replaced it with 0. What about this first 2 to the power k? Where did that go?
No, that doesn't go anywhere. This is what our answer is. 2 raised to k.
Okay, so like okay, okay, okay.
Okay.
That's constant. I thought
Okay.
you replaced that
No,
first
no,
term with 0.
no, no, no.
Got it, sir. Got it.
Okay, okay. No
Oh,
worries. Yeah. So guys, please try on your own and let me know if you have any doubt. Okay. So we'll discuss and we'll take that. And in the next class, like yeah, Ankit, I'll share this on GitHub. Like every day, I share the notes and code of that, right? So on the similar kind of thing, I'll share the notes of this. You can access from that. Okay, is that okay? Now, in the today's class, we learned about how to find complexities for recursive solution. From the next class we'll revise this particular entire thing what we have learned till now, you know, we'll solve some more problems, and from the next to next class onwards we'll quickly move towards the sorting thing. Okay, there are many sorting algorithms that we need to learn. We'll slowly learn this entire thing. In each and every algorithm we'll find the best case, worst case and average case. Okay, so you need not to worry. Anyway, this will come till the last day of your course. Okay, okay people, Fine. Any doubt till this particular point? Ekta, yeah. Today's homework would be that you need to solve. Uh, just a second. The question was in my mind about the recursion. Just a second. Or else, yeah, do one thing. Do one thing. Today we have covered a lot of things. Okay. So today you just need to revise this thing from tomorrow's class. From next class onwards, I'll give homework. I'll give one problem every day in every class as a homework. Okay. Making sense? So you will realize that it in each week we will learn five new problems, or else like not five, just three problems, to be honest, because many problems would be much more difficult, and also like this thing also. Okay. So like on an average we'll learn three problems in each week, so in the entire month we'll learn 12 new problems. And calculate kar lo कि how many months you have remaining in this. Okay. So basically you will be in the benefit, a lot of benefit if you just solve one problem or two problem a day. That will be like making like really big impact. So how system knows about time complexity? Nishant, system will, like this is not done for system. This is done for ourselves. Like we have to evaluate now which code is better. This is for comparison purpose. This is not for system purpose. Like of course this will be run on system, but there will no matter like system will get hang or system will do something else. There's not that doesn't matter. Like we are doing this at the end of the day, we are doing this for a system purpose, like it can run smoothly on our code, many user will come, they will not hamper each and everything, you know. We'll also take care of about the space complexity as well, but this thing can be calculated on paper, that is why we are calculating it. Okay. We solve array of 2D problem. uh till now we learn only this thing. Like Deepak, what do you mean to say? Can we solve array and 2D array problem? Okay, Deepak, you are not confident in that. In DSA, yeah, you can solve any problem in this class, because in this class I'll not give you homework, because many things you have to learn in this particular class. Okay, because I think so. Today's class you have learned many things new, na? So you need to practice that also. So please practice that. Please solve some more problems on your own if you are comfortable in that. And from next class onwards, I'll keep that in mind that every day in every class I'll make one problem as a homework. If you have any doubt, you can ask me in doubt session, or else you can solve it in the TS class. Okay. I'll prefer to to solve that particular thing in TS class, because this will be having more, like we can solve more thing in doubt also, no? So doubt session will not fill up with this doubts only. Okay, making sense, people? Deepak, I'll say that after like this week and the next week, most probably till the next week or the next week. Okay, like max to max like 15 days, then after we'll quickly move to the node.js. Okay, we need to learn first like sorting thing, and all this basic thing is still remaining, so we will complete that, then after we'll move to the development part. Okay, Deepak, but this thing will take time, do not rush. Okay, do not rush and do not hurry, take baby steps. Do not try to climb a mountain in a one go. Okay, take baby steps, you will be able to climb it. Okay. Any doubt, any general query, any sorts of any problem, I'll upload this particular PDF in the in GitHub. Okay. Chalo. Sir, in yesterday's permutation problem I have a small doubt at post self work. Okay, yeah, please ask. Okay, just a second, I think so I have that problem. Okay, I'll share that, just a second. Hmm, just give me a moment. This one, na? Who was that? Joseph. This one, the class. This one, so the problem. Everyone else can leave if they don't have any doubt. Okay, they can leave, no problem. We'll solve that doubt with Joseph. Okay, Joseph. Yeah, this one. So then the post permutation, what we have, post self work. So let's say in which line? Can you say in which line? This line. Okay. So in this line, what we are doing? First of all, what we did, we swapped the elements, we permuted, we recursively call our function, and then again we did the permutation or swapping thing. Because if you see, if you do ABC, how remaining combinations are done. Joseph, can you do one thing? Do you have like did you debug this? Did you debug this? Because if you have debugged, no. So I'll say that Joseph, I'll highly recommend that first you will try to debug this on your own. Okay. After that, I'll make sure that I'll solve it out. But if you debug on yourself now, you will get to know more things. Okay. Do you know how to debug and how to see the call stack? Yes or no? So see, every time this function will be called, है ना? Every time this function will be called, and this l plus 1 is what? My index will be increased every time, है ना? First of all, we are calling it with 0. Let's see if I have a b c. So I'm standing first of all here. I have to go here first of all, है ना? Then after I will do swapping, if you remember, है ना? So see this particular thing in action in call stack, and then after we will solve it if you have any doubt. Making sense, people? Joseph, ठीक है ना? ठीक है, चलो. So we'll meet on Wednesday class, and in that particular class, we'll solve some more problem with this particular thing. Joseph, am I clear? I hope so. Will it be fine with you? After returning from base case, remaining combinations. Okay, so see, what we are doing in the natural call stack. Okay, suppose if you are initiating like this is my permutation one, permutation two, permutation three, permutation four. Now मान लो यहाँ से I am hitting my base case. So it will return from here. It will return everything to this. It will return everything to this. It will return everything to this. Now, if you see here, every time in every base case, we are printing out, right? And then after we are swapping. So anyhow, our combination will be covered. Joseph, am I making sense? Yes or no? Okay. Okay. Just see this thing in action in call stack, and then after you will get to realizing what is happening inside. Okay. So please make a habit of debug if you don't understand any random problem also. This is like I am with you right now today, but see for an example after 2 years, I man lo ki I'm not there with you to solve or to resolve your doubts. So this is how you will debug on your own. This is the very important thing to learn. है ना? I hope you are agreeing with me. Okay? So please do that, and then after we'll quickly solve this. Okay? So on that note, everyone, good night, and we'll meet on the Wednesday's class. Okay, I'm uploading this thing right now. Okay, okay. Good night, everyone. Good night, Vishal. Thank you, Ikta. Chalo, good night, Sasin. Bye.